If you've ever looked at HVAC drawings or equipment schedules, you've probably seen acronyms like AHU, RTU, VAV, DDC, and BES. In this video, we'll explain 55 of the most common HVAC and construction acronyms you'll encounter on commercial projects. Whether you're an estimator, engineer, project manager, technician, or new to the industry, these are terms you'll want to know. Let's get started. Number 1. AHU, Air Handling Unit. An AHU conditions and moves air throughout a building. It typically contains filters, heating and cooling coils, dampers, and supply fans. You'll commonly find AHUs in mechanical rooms, penthouses, and on rooftops. Number 2. RTU, Rooftop Unit. An RTU is a packaged HVAC system installed on a building's roof. It typically combines heating, cooling, filtration, fans, and controls in one factory-built unit and is commonly used in offices, schools, retail stores, and warehouses. Number 3. FCU, Fan Coil Unit. An FCU is a smaller HVAC unit containing a fan and heating or cooling coil. It typically serves an individual room or zone and is commonly found in hotels, apartments, hospitals, and office buildings. Number 4. MAU, Makeup Air Unit. A makeup air unit replaces air removed by exhaust systems. It brings outdoor air into the building and typically filters, heats, or cools it before supplying it indoors. MAUs are common in commercial kitchens, laboratories, and industrial facilities. Number 5. ERU, Energy Recovery Unit. An ERU transfers energy between outgoing exhaust air and incoming outdoor air. This reduces the amount of heating or cooling required to condition the outdoor air and helps lower building energy consumption. Number 6. ERV, Energy Recovery Ventilator. An ERV provides ventilation while transferring both heat and moisture between the outgoing and incoming air streams. This reduces heating and cooling loads while bringing fresh outdoor air into the building. Number 7. HRV, Heat Recovery Ventilator. An HRV also recovers energy from exhaust air, but primarily transfers sensible heat rather than moisture. It's especially useful in colder climates, where heat from outgoing air can help warm incoming outdoor air. Number 8. VAV, Variable Air Volume. A VAV system varies the amount of conditioned air supplied to a space as its heating or cooling load changes. VAV systems are widely used in commercial buildings because they provide individual zone control while reducing energy consumption. Number 9. CAV, Constant Air Volume. A CAV system delivers approximately the same amount of air continuously. Instead of varying airflow like a VAV system, temperature is typically controlled by changing the temperature of the supplied air. Number 10. VRF, Variable Refrigerant Flow. A VRF system circulates refrigerant between an outdoor unit and multiple indoor units. Refrigerant flow changes with demand, allowing individual zones to independently heat or cool while providing efficient operation. Next, let's look at some of the most common acronyms used to describe HVAC airflow. Number 11. SA, Supply Air. Supply air is the conditioned air delivered from HVAC equipment into occupied spaces through ductwork, diffusers, and grills. Depending on the system, supply air may provide cooling, heating, ventilation, or a combination of these. Number 12. RA, Return Air. Return air is air drawn from occupied spaces back toward the HVAC equipment. It is typically filtered, mixed with outdoor air as required, conditioned again, and recirculated through the building. Number 13. OA, Outside Air. Outside air is fresh air brought into the HVAC system for building ventilation. It helps dilute indoor contaminants and maintain acceptable indoor air quality but must usually be heated or cooled before entering occupied spaces. Number 14. EA, Exhaust Air. Exhaust air is air intentionally removed from a building and discharged outdoors. Exhaust systems are commonly used for restrooms, kitchens, laboratories, locker rooms, and other spaces where odors, moisture, or contaminants must be removed. Number 15. TA, transfer air. Transfer air moves from one room or space to another without first returning to the HVAC equipment. It may pass through door undercuts, transfer grills, or transfer ducts to help maintain proper airflow and room pressure relationships. Number 16. CFM, cubic feet per minute. CFM measures the volume of air moving through an HVAC system. It's one of the industry's most common airflow measurements and is used for sizing ductwork, selecting equipment, and balancing air systems. Number 17. FPM, feet per minute. FPM measures the velocity or speed of air moving through a duct or opening. Remember the difference. CFM measures airflow volume, while FPM measures air velocity. Number 18. ESP, external static pressure. External static pressure represents the resistance an HVAC fan must overcome from components external to the equipment, such as ductwork and other system components. It's an important value when selecting equipment and evaluating fan performance. Number 19. TSP, total static pressure. Total static pressure represents the overall static pressure difference across the fan and is used when evaluating fan and air system performance. It provides a broader picture of the pressure the fan must produce to move the required airflow. Number 20. ACH, air changes per hour. ACH describes how many times the volume of air within a space is replaced or exchanged during 1 hour. It's commonly used when evaluating ventilation in hospitals, laboratories, clean rooms, and other specialty spaces. Next, let's move into some common heating and cooling acronyms you'll encounter on HVAC equipment schedules and piping diagrams. Number 21. DX, direct expansion. A DX system cools air by circulating refrigerant directly through a cooling coil. It's commonly used in rooftop units, packaged equipment, split systems, and other HVAC equipment that doesn't rely on a central chilled water system. Number 22. CHW, chilled water. Chilled water is cold water produced by a chiller and circulated to cooling coils in air handling units, fan coil units, and other HVAC equipment. The water absorbs heat from the air and carries it back toward the chiller. Number 23. CHWR, chilled water return. Chilled water return is the warmer water returning to the chiller after absorbing heat at the cooling coils. The chiller removes that heat, cools the water again, and sends it back through the chilled water supply system. Number 24. HHW, heating hot water. Heating hot water is circulated through heating coils in air handlers, fan coil units, and other HVAC equipment. The hot water transfers heat to the air, passing across the coil to provide space heating. Number 25. HHWR, heating hot water return. Heating hot water return is the cooler water returning after releasing some of its heat into the HVAC system. It returns to the boiler or other heating source, where it's reheated and circulated again. Number 26. BTU, British Thermal Unit. A BTU is a unit used to measure heat energy. 1 BTU is approximately the amount of heat required to raise 1 pound of water by 1 degree Fahrenheit. Number 27. BTUH, British Thermal Units per hour. BTUH measures the rate at which heat is added or removed. HVAC equipment heating and cooling capacities are commonly expressed in BTUs per hour. Number 28. MBH, 1000 BTUs per hour. MBH is another HVAC capacity measurement, with 1 MBH equal to 1000 BTUs per hour. For example, equipment rated at 250 MBH has a capacity of 250,000 BTUs per hour. Number 29. COP, coefficient of performance. COP is a measure of HVAC equipment efficiency. It compares the useful heating or cooling produced to the energy consumed, with a higher COP indicating greater efficiency under the specified operating conditions. Number 30. EER, Energy Efficiency Ratio. EER measures the cooling efficiency of air conditioning equipment at specified test conditions. A higher EER indicates that the equipment produces more cooling for the electrical power it consumes. Next, let's look at the acronyms behind the controls and automation systems that operate today's commercial HVAC equipment. Number 31. BAS, Building Automation System. A BAS is a centralized system used to monitor and control building equipment. It commonly manages HVAC operation, temperatures, schedules, alarms, and energy use throughout a commercial building. Number 32. BMS, Building Management System. BMS is often used interchangeably with BAS, although a BMS may integrate additional building systems such as lighting, electrical power, security, and other facility operations. Number 33. DDC, Direct Digital Control. DDC uses electronic controllers to automatically operate HVAC equipment. Controllers receive information from sensors and adjust devices such as dampers, valves, and variable frequency drives to maintain programmed conditions. Number 34. VFD, Variable Frequency Drive. A VFD controls the speed of an electric motor. In HVAC systems, they're commonly used on fans and pumps, allowing motor speed to change with system demand and significantly reducing energy consumption. Number 35. BACnet, Building Automation and Control Network. BACnet is a communication protocol widely used in building automation. It allows HVAC equipment and control systems from different manufacturers to exchange information and operate together. Number 36. PLC, Programmable Logic Controller. A PLC is a rugged industrial computer used to automate equipment and processes. In HVAC, PLCs are often found in central plants, industrial facilities, and other applications requiring complex control sequences. Number 37. PID, Proportional, Integral, Derivative. PID is a control method used to continuously adjust HVAC equipment to maintain a desired set point. It can modulate valves, dampers, and motor speeds to maintain stable temperatures, pressures, or airflow. Number 38. AI, Analog Input. An analog input is a variable signal received by a controller from a sensor. Temperature, humidity, pressure, and airflow sensors are common examples because their measured values continuously change. Number 39. AO, Analog Output. An analog output is a variable signal sent from a controller to a device. It's commonly used to modulate control valves, dampers, and variable frequency drives rather than simply turning them on or off. Number 40. DI and DO, Digital Input and Digital Output. Digital signals typically represent two states, such as on or off. A digital input receives status information, while a digital output sends a command, such as starting or stopping a fan. Next, let's look at several acronyms associated with indoor air quality, filtration, and environmental conditions inside a building. Number 41. IAQ, Indoor Air Quality. IAQ refers to the quality of the air inside a building and how it affects occupant health and comfort. Ventilation, filtration, humidity, temperature, and airborne contaminants all contribute to indoor air quality. Number 42. MERV, Minimum Efficiency Reporting Value. MERV is a rating used to describe an air filter's ability to capture airborne particles. In general, higher MERV ratings indicate better filtration of smaller particles, but they can also create greater resistance to airflow. Number 43. HEPA, High Efficiency Particulate Air. HEPA filters provide very high levels of particle filtration and are commonly used in hospitals, clean rooms, laboratories, and other critical environments where airborne contamination must be carefully controlled. Number 44. UVGI, Ultraviolet Germicidal Irradiation. UVGI uses ultraviolet light to help inactivate microorganisms such as bacteria, viruses, and mold. In HVAC systems, UVGI is often installed near cooling coils or within air handling equipment as an additional layer of air treatment. Number 45. RH, Relative Humidity. Relative humidity describes the amount of moisture in the air compared with the maximum amount the air can hold at that temperature. Controlling RH is important for occupant comfort, indoor air quality, and preventing excessive moisture and mold growth. Finally, let's look at 10 common construction and project acronyms that HVAC contractors encounter throughout the bidding, construction, and closeout process. Number 46. RFI, Request for Information. An RFI is a formal question submitted when the construction documents require clarification. Contractors commonly use RFIs to resolve missing information, drawing conflicts, unclear requirements, or other issues before proceeding with the work. Number 47. IFC, issued for construction. IFC identifies drawings or documents that have been issued for use in constructing the project. These documents provide the current design information contractors use to perform and coordinate their work. Number 48. VE, value engineering. Value engineering evaluates alternative materials, equipment, or construction methods to reduce cost or improve value while maintaining the required performance and functionality. True VE is about improving value, not simply selecting the cheapest option. Number 49. TAB, testing, adjusting, and balancing. TAB is the process of testing and adjusting an HVAC system to achieve the specified airflow and water flow. It helps verify that the completed system operates according to the design requirements. Number 50. O&M, operation and maintenance. O&M refers to the information provided to the building owner for operating and maintaining installed equipment. O&M manuals commonly include equipment data, maintenance procedures, warranties, startup information, and operating instructions. Number 51. ASI, Architect's Supplemental Instructions. An ASI is issued by the architect to provide supplemental instructions, interpretations, or minor changes to the work. It's generally used when the change does not modify the contract sum or contract time. Number 52. CCD, Construction Change Directive. A CCD directs a change in the work before the contractor and owner have necessarily agreed on the final adjustment to cost or time. It allows necessary construction work to proceed while those impacts are resolved. Number 53. CO, change order. A change order formally modifies the construction contract. It may change the scope of work, contract amount, project schedule, or a combination of these after approval by the required parties. Number 54. NTP, notice to proceed. A notice to proceed formally authorizes the contractor to begin the work. Depending on the contract, it may also establish the date when the project's contract time begins. Number 55. PCO, proposed change order. A PCO is a proposed change submitted for review before becoming a formal change order. It typically identifies the scope change along with the proposed adjustment to contract cost, schedule, or both. And there you have it. 55 common HVAC and construction acronyms you're likely to encounter on commercial projects. Whether you're an estimator, engineer, project manager, technician, or just getting started in the HVAC industry, understanding this terminology will make drawings, specifications, equipment schedules, and project documents much easier to navigate. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business